Hi and welcome to Programming Percy. Today we will be looking at how to develop and debug Lambdas locally using SAM. Lambdas is an AWS service which allows you to take small pieces of code and deploy them to the cloud and execute them based on a number of events, such as an API call or an SQS event or a S3 event and many other AWS services. However, debugging these lambdas can be tricky sometimes because they are meant to be run in the cloud. And SAM is a AWS tool which stands for Serverless Application Model, and it's a toolkit that helps us develop and use these lambdas on your development machine instead of the cloud, which is great. So during this tutorial there is one thing I will kind of expect you to already have, and it's an AWS account and also the AWS command line tooling installed and configured. And if you don't have that, there's a link up here which you can use to find out how to set that up. So SAM. About SAM. Who is SAM? SAM is a framework that allows us to develop cloud applications. And a cloud application is many cloud resources, and one lambda is a resource. So you have one lambda as a resource which builds into a application when you have many. And we will be beginning by learning how to develop these lambdas and also how to debug them. So SAM is a command line tool, so it's IDE agnostic. I know many people think you need Visual Studio Code for this, but you don't. You can use any kind of IDE that you want. I will be using VS Code in this tutorial, however. So let's begin by downloading and installing SAM. So you can download SAM by visiting the website or also using vget to download the zip file, which is what I will do. So let's vget this file, and don't worry about copying the path to it. You can find the URL in the description. So once we have that, it's time to unzip the zip file, and we will place it in SAM installation folder. So there's a bunch of files being unzipped. You don't have to care about them. There's only one file that we care about, and it's the installation file. So we will run that as sudo. So going to the SAM installation folder, locate this install script and trigger that as sudo. Now I already have SAM installed, so mine will tell me that I can update instead, but if you don't have SAM installed, it will install. You can verify that SAM is installed by doing SAM -- version, and it will print the current installed version of SAM. So now that we have it, we can remove the zip file. We can also remove the SAM installation folder. We don't need that anymore. If you're unsure, you can verify by calling SAM -- version again. So it's running. Great. Let's begin developing our first lambda. It will be a very simple lambda, and in this tutorial we will be using Golang, but you can use any language that supports lambdas. You can find all the supported languages in the AWS documentation, and I will put a link in the description. If you want to use another language, you can go to the chapters in the docs called working with Node, working with C, working with whatever you want. But let's go ahead. I'm in my SAM demo folder here, which I have created, which is a blank folder. And we will go ahead and create the module, Golang module. So we will go mod init programming Percy, which is my module, and I will also create a main file, which will be our lambda, and I will also create a template.jam. We can leave YAML file for now. It's the SAM YAML, which we will use to define the SAM cloud architecture, but our lambda will be placed in the main.go. So let's go inside of it and see how a lambda works. we will have the main package. And the main package is just because this lambda will be a single binary which you can execute. So let's just leave it at that. And we will have a input to our lambda, and that input will be a event. And you usually, when talking about lambdas, you talk about events, because you talk about other AWS services that can trigger these events. So let us say that the triggerer of our lambda will input his or her name as an input. So our struct will accept a JSON with the name. And we also need the actual lambda function. So let's call it lambda handler, which is a bad name, but leave it at that. So lambda handler, and our lambda handler will accept the event as input, and we will output a string and an error. So what we will do in our lambda is very simple. We will simply prefix the inputted name with a hello. So we will do sprintf hello from lambda, and the name is contained inside the event.name, and we will return this to the user. Now we also need to make a main function, because this is a main package in Go. So we create the main function, and what you will do in the main function is that you will use the AWS SDK for triggering lambdas. So in this file it will be lambda.start, and we will pass in the lambda handler. Now you can see my IDE wants to pass the actual function call, so it triggers lambda handlers and returns the output from it, but that's not what we want to do. We want to start the lambda and input the function without calling it as input. So whenever our lambda is triggered, it will execute the lambda handler function. It won't trigger the main function, it will trigger the lambda handler. And go ahead and import that, and it will complain a bit because we need to fetch the SDK. So I will do go mod tidy, and it will download and install. Great, this is our first lambda. It's as simple as this. Now before we begin executing our lambda, because we can't execute this locally because the lambda.start prevents us from doing that. So let's go ahead and see what we can do with SAM. So SAM is a template built cloud architecture tooling. And what that means is that we write our architecture as code, so infrastructure as code. And actually SAM is an extension of CloudFormation. If you're familiar with CloudFormation, this will be very familiar. So inside the template.yaml, we will create our SAM application. So let's create, and the first thing you want to do is you want to specify the actual SAM version to use for the templating engine, and this will always be 2010-0909. I know this is very old, but that's the only accepted value for now according to the documentation, so leave it as that. You will also specify a transform, and it will be AWS : serverless, and this dates. And again, it will always be these dates, so whenever I start a new SAM, I just copy paste these in because they have been the same for years. Now let's begin by adding a description. So this is a description for your whole cloud architecture. So in this case it's a demo of SAM, and we try out SAM. Just pass in whatever. The next thing we want is something called globals, and globals are interesting because this is how we define configurations for all of our resources. Now in our case we want to say that our Lambda functions cannot execute for any longer than 5 seconds. So what we do is we say globals, we say apply these global to function, and we specify what we want to configure. So the timeout is for 5 seconds. There's a bunch of globals that you can configure, and you will find it in the documentation. Again, I put all the documentation links in the description. Next up, it's finally time to start defining our application. And the way you do that is, again, by specifying the resources. So let's go ahead and add resources. And our resource will be named Hello Gopher because it says hello to the gophers who calls it. And you specify the type. All SAM resources will have a type defined, and the type is what kind of resource it is. In our case it's a Lambda, but it could be an SQSQ, it could be an S3, but let's leave it at the Lambda for now. And a Lambda is a AWS serverless function. That's the same thing. So this is the way to create the Lambda. Now a resource also accepts something called properties, and properties are configurations specific to the type. So depending on the type you set, you can define certain properties. In the Lambda case, we will need to define the code URI, which is the path to the code that will be executed. And we go ahead and put in code URI, and in our case our code is inside the root folder, so you can just leave it as this. However, this could also be an S3 path or a path to a zip file. We also specify the handler, which is basically the name of the Lambda. Now we also specify the runtime, which is the Golang version to use when executing the Lambda. And we can specify the architectures to use. In our case it will be x86_64. Now this is it for the Lambda. To start out, we specify that we have a function type, and we set the code URI to point to the code. We will look into how to change this later, because having the Lambda in the root usually isn't what you want. Now we can actually try running this. So you go into the command line tool and you do SAM local invoke, which is the command to execute a Lambda locally. So SAM local invoke will actually invoke this Lambda that we have specified in the template. So it will look inside the template and see we have a function, it's located in the root, and execute it. Now we will see an error, and this is to be expected because we have only defined the resources, we haven't built them yet. So let's go ahead and build them in the next step. So to execute it properly, we need to build the SAM application, and the way to do that is very easy. You go ahead and type SAM build, and it will compile your code into the Lambda, and you will see a bunch of output here stating that you can now deploy it, which you could, but since our application really isn't that great yet, let's not deploy it. But you can find this folder called AWS SAM, which has a build folder, and you can see our Lambda is actually located here, Hello Gopher, and it contains the binary. Now this is built using the correct architecture, the correct version, and the path we set. So now we can go ahead and invoke again. SAM local invoke to execute it, and go ahead and pass that, and you will see it runs hello from Lambda. One thing is missing, and it's the name. So remember that we built a event as input. We actually have to pass something into this Lambda to work. Now we don't validate the input in this Lambda, but in a real Lambda you would. But let's look at how we can insert data into the Lambda as well. So SAM local invoke contains a flag which is -e, which stands for event. And this is the way to pass in information. Now to pass in data, you can create a file and we will name it event.json, and event.json will contain our JSON formatted input, which was name and some name. My name is Percy, so I'll leave that. Now we can pass this event file into our Lambda when we execute it. So we can go ahead and do SAM local invoke -e, because it's the event flag, and point to the event.json. Now when we run it, you will see it executes, and now hello from Lambda, Percy. This is great. That's what we wanted. Now this is the way we can pass in data to the Lambdas, which is great. And SAM local invoke takes in a bunch of other flags. We will look into the -d flag later, which is the debug flag, which you can use to attach a debugger. Also, you want sometimes to invoke a certain Lambda, because now we just said SAM local invoke and it worked. But if you have multiple Lambdas, that won't work because it will execute the first one. So to do another invocation and specifying the Lambda, you do SAM local invoke, but then you specify the Lambda name, which in our case was not hello gopher. Actually, it actually tells you. So this is great about SAM. It has our template file, so it actually knows the name of the resources. So you can see here, it tells me to, then it corrects me basically saying this is the name. We can do that instead, and we should see it execute. So that's great, because we can now have our Lambda executed correctly. Now sometimes you have other services who executes Lambdas, and you might want to test that locally as well, but you don't want to use the command line tool for that. You don't want your programs to execute SAM local invoke. And to manage that, you can set up a fake AWS Lambda API. Not an HTTP API, we will look into that later, but you can do SAM local start Lambda, and it will start up a Lambda API. And what that means is you can now execute Lambdas as you would a regular AWS Lambda. So if we open up a new terminal, we can use the regular AWS command line tool, so not SAM but AWS, and do SAM Lambda invoke. And this is the way you would invoke a real Lambda from AWS. So the function name is the same as when we did the invoke, so hello gopher. And the endpoint is not on AWS anymore, but rather hosted on this URL you find here. So instead of going to AWS, it will go to your local machine. So the endpoint is HTTP localhost 3001. And we also want to specify the payload, and I failed. So the payload should be the JSON payload, same as before. So we do name, and my name is again Percy, so let's close up the JSON there. Right, AWS Lambda invoke also wants an output file, so we need to specify response.json. Now it will actually invoke my Lambda. If we switch terminal here, you can see that it invoked, and we can go in here and see the output. It's a status code 200. And if we open up response.json, hello from Lambda Percy. So this is great. And this is very useful if you have, say, a React website which uses your Lambdas. You can just point them to the localhost instead. So many times you don't want to have a Lambda API exposed. Many times when you develop Lambdas you want a HTTP API exposed to other services. And we can do this using an API gateway, which is a AWS service which exposes your Lambdas as HTTP, and that's really easy to add using SAM. So what we will do is that we will open up template.yaml again, and in here we will define that this Lambda, or hello Gopher Lambda, is expecting to be triggered by a certain event type. And you do that by stating events. Now you could have multiple events. In this case we will only have a HTTP event trigger it. And we will call this resource hello endpoint. This is our HTTP endpoint. And we also have to state, by again using type, that this is a API. Now when you say that this is an API, as we do here, SAM will automatically know that this is a API gateway that needs to be created. So if I were to deploy this using SAM, it would actually create and set up the whole API gateway for you. And you can also add some properties to this, because we want to configure some things, such as the path where you will call the API. In our case we will have /API/hello Gopher. And we will also want the HTTP method declared. And in our case we want to have posts. So this simple few lines will allow SAM to create an HTTP API for us. So before we move on, we will need to modify the Lambda somewhat, because when we have a API gateway in front of it, it will modify how the input event in the Lambda looks like. Now the AWS SDK comes with a events library which you can import, and in there you can find all the different events that exists from different services. So if we go ahead and do that, our input event will be an API event instead. So we go ahead and go events.api. You can see here how many there is. There's a ton, and this is just for the gateway. There is a ton of different events, depending on if it's a DynamoDB event, S3 event, IoT event, Kinesis, Kafka. There's a bunch of predefined events. Now we'll look more into other events later. So let's go ahead and add API gateway proxy request, because this is how the request will look like when we get it. You can see there's a bunch of things. The user input will be inside the body, so we will need to handle that. But before we do that, we also want to modify that the output from our API will be an API gateway proxy response. And the reason why we do it, you actually don't have to change the event types. You can make it work anyways, but it's pretty nice because AWS will append invocation IDs and stuff into the requests automatically, so which can be very nice to have. So let's go ahead. We will need to create a input which will be our custom event type, and into that we will marshal the user payload, because the input from the user will still look the same. So let's go ahead, if error, and we will unmarshal the JSON. And remember that the input from the user was a string, so we need to convert that to a byte array. And the payload was located in the body, and we want to marshal into our input, and we need to check that the error isn't nil. Now if it is, we will return the error message as the body. Again, it's a string, so you need to invoke the error function. And then the status code should be HTTP internal server error. And we also return an error. In our case, let's return the error. So now we can do the same thing as before, but instead we want to grab the name from input, which is our event struct. And we also want to change the return type. It should be an events API response. And the body should be our string that we formatted. And status code will be HTTP status OK. So once we've changed this, we can go ahead and retry the Lambda as an API instead. So we can go ahead and go SAM build, which will rebuild the Lambda because we changed the code. And then you can go, instead of running SAM local start Lambda, which started our Lambda API, we can now run start API, which will start an HTTP API for us. So let's go ahead and run that. Start API, and we can see that it's on port 3000 this time instead, to not collide with the other. And we can go ahead and do a curl to verify that everything is working. So we will curl to localhost 3000, and remember we added the path to the API before in the template. Here we said that the API should be hosted on /API/hello gopher, so we need to add that. Hello gopher. And we also need to pass in the data, and the data will be the same as before. So the same name JSON, and again Percy as name. And now when we trigger that, we should see a response. So let's think, hello from Lambda Percy. So now we're hosting our Lambda as an HTTP API. And that's amazing. So many times in our APIs we will need to use environment variables. And SAM comes with a way to handle environment variables. Because now we have one Lambda, which we can configure pretty easily, but you might have many. I've seen like a ton of Lambdas, so handling the environments can be quite messy. But SAM helps us again. So what we can do is, in the template, we can actually add all available environment variables. And remember that you need to add them to the template to be able to change them later. So if we define my cool variable, maybe not so cool, the Lambda will now have access to the environment variable my cool variable. And that's trivial, but when we add it in the template, we actually tell SAM that this environment variable exists, so you can modify that one. And what that enables us to do, or let's first add the output to print the environment variable, so we can actually see that we can change it. So let's go ahead and add here the variable to the output. The variable is, and let's print that as well. And let's get it, my cool variable. So this will add the variable to the output. And we set the value to maybe not so cool, but we can actually change this now using a small trick. Let's add a new file called environments.json. And this is a file which we can use to configure multiple Lambda resources. So we start by saying inside the JSON which resource we want to configure. So in our case we want to configure hello gopher, and we want to provide my cool variable with a new value of now it is much cooler. Now if I were to change test variable here, this would not apply because test variable is not defined in the template. Remember, if it's not defined in the template, you can't change it. So we can only change my cool variable for now. So let's leave it like that. And what we can do is we can take this environment file and pass it into the SAM local start. We can also pass this environment flag into the deployment. So that's one way of doing the deployment. But let's go ahead and we can do SAM build because we updated the Lambda. So, and then we can do SAM local start API, and we can use the -n flag, which accepts a path to a environments file. So if we go ahead and run that, everything will run as usual, and we can curl it again, and this time it will print the variable is now so much cooler. So that's how you can easily manipulate many lambdas at once using environments. So one other common approach to lambdas is that the lambda should be triggered depending on what another AWS service does, such as one very common use case is that you might have an SQS queue which publishes events and you want your lambda to trigger on them. Now we can't make SAM listen to an actual SQS queue, which is sad, but there's ways to manage. And the way you handle it in SAM is that you can generate events. These will be fake payloads that you generate, which you can push to the Lambda. So it will work exactly as a real SQS event were triggered, but you don't need SQS to actually trigger it. And to try that out, let's go ahead and add a second Lambda resource to our templates. And don't worry, it won't be too long, it's very short. So let's call it SQS Lambda, just because our naming is very bad. And again, it's a Lambda, so you go ahead and do the serverless function, and we need the properties to start it. And let's go ahead and add the codejury. Now codejury points to the Lambda file that should be executed, and the last one was in the root, which is bad. I usually create a folder named Lambdas or something, so you can store your Lambdas in there in a more structured manner. So let's go ahead and add the SQS Lambda. Again, this is, you could do Lambda and then a folder inside there named SQS Lambda or whatever, but just to show you how it works. So we need to point the codejury to that, and again the handler would be SQS Lambda. We need to specify, same as before, the runtime. And let's not complex it, so let's leave it as before. And we have our new Lambda. But we want this Lambda to trigger on SQS events. So the same way we did with the API, we can do the same thing with SQS instead. So the way to do that is, again, we use the events. Actually, you could put multiple events here, so you could have this hello Lambda trigger on SQS as well. You can have multiple inputs. But let's create a new one to see it roll. So we have SQS events, which is our name. You can set anything there. The type is important. This type is an SQS event. And you have to specify the properties, and in the SQS type you only need one, and it's the name of the queue or the arn of the queue. So let's go ahead, my awesome queue. Now this is everything we need to set up our new Lambda, but we actually need to create the Lambda as well. So let's go ahead and do that, because I want to show you how we can generate these SQS events. So we have here, let's go ahead and create a main.co, and it's the package main, and this will be a very simple Lambda. So we have our Lambda handler, and the input should be an SQS event, which is predefined in the SDK, and you can see that we can actually very quickly review it. It's an array or a slice of SQS messages, and it contains a bunch of information. So mocking this can be troublesome or annoying, but happily we can generate this output for us. So let's make our Lambda return an error, and we will simply log the event to the standard out, so we can see that the event is generated, and we will return nil. And then we need a main function, and in the main function we should do lambda start our Lambda handler. And again, my IDE always wants to execute the function instead of passing it as an argument. So here is our SQS Lambda. It's not much, but it's working. So what we can do now, because you don't want to create this big JSON struct yourself, let's make Sam do that for us. So what we can do is we can do sam local generate event. If you trigger that, you will see all the supported services. So depending on what AWS service you have, you can actually create events for most of them. And let's go ahead and see if we type SQS, which is the service we want to use. It will tell us that there's one available command, which is receive message. Hopefully we will see send message, but it's not a big problem for now. So let's receive a message, and we will specify the body. The body is the user payload. So again, always body is the user payload, so we want to modify only that, because all the other data is sort of this generated AWS data or metadata about the invocation. So let's go ahead and say that this is my own event payload. Now I misspelled the command, so it's receive. Oh, there we go. So now you can see that we got a big JSON payload outputted, which is what the real AWS SQS will output. And instead of copy and paste this, we can actually make Sam generate this, and we can pass this from standard out into the Lambda. So if we pipe this, we can do Sam local invoke, and we want to do the -e because this is the input event. Remember, before we passed a path to the event.json, but this time we will pass a single dash, which says the payload will come from standard in, and the standard in will get the output from the generate message command. So we generate the message and we pass that into the standard in of the Lambda. And we also need to specify which Lambda will receive the payload, and it will be our SQS Lambda. So if I go ahead and run this, we need to build, do sam build, and it will build the application, and now you can run the same command. So let's see, it is finding the Lambda, and we can see something was logged to standard out, and you can see here that it's the metadata and also our payload. So this is how you can generate events and pass them into the SAM Lambda. So we finally know the basics of SAM, and it's time to start looking at how we can debug our functions, which is a very important aspect. And what we do is all the commands to invoke a Lambda in SAM So SAM start Lambda, SAM start API, SAM invoke, all except a -d flag, which is the debug flag. And what will happen if you pass the D flag is that you will specify a port, and the Lambda will know to host a debug on that port, and it will halt all executions until a remote debugger is attached. So let's take a look at how to do that. It's very easy actually. So what we do is we need to specify a few options. You need a debugger installed because the debugger should be installed on your host machine. In Golang we often use Delve, so you should go ahead and install Delve if you're trying this with Golang, and I'll put a link in the description on how to install it. And you also need to set your Gobin so you know where the Delve binary is installed. So let's go ahead and start invoking a Lambda. We will invoke our SQS Lambda, and we will use the D flag and say on port 8099 you should host the debugger, and we need to tell the SAM application that the debugger to use is located in a path on our host machine. So we use the debugger path, and we set that to, I have my go bin in home Percy go bin, so that's the path I will use. And also I want to use Delve version 2, so you should also do that because that's the new version. And you do that by doing debug args and then pass in the flags to apply, which is Delve API equals 2. Now if I execute this command, my Lambda will start up and we can actually execute it. We will see the Lambda start up and it will tell us a few things, and it will stop because it's now waiting for a debugger to attach before continuing. So let's attach a debugger. Now you can use any, I know Golang has a remote debug option, and you can do the same in VS Code. So let's go ahead and create a new file or a new folder named .vscode, which is the place you should put your debug configurations in VS Code, and we should put it in launch.json. The naming is important because this is how the VS Code editor knows how to locate the files. And this is how you specify debugger and debugging options in VS Code. So let's create our specific one, and it's debug with SAM. This is the name, so you can put whatever you want. And we want to tell the debugger to use Golang, and this is important. The request is not a launch request, it's an attach request because we want to attach to a debugger. And we will set the mode. You can set either local or remote, and we want to set remote because we are attaching to a remote debugger. It's actually still on your computer, but it's on the remote Docker, which is not on the same network. So go ahead and say the port, which is 8099. Make sure you put the same port which you used to the D flag in the SAM local invoke command. And the host, in our case it's localhost. So once you have created your launch JSON with this configuration, you can go inside here in the debug options, and you should now see debug with SAM appear. And you can execute this debug, which will connect to the SAM Lambda which is running. But before we do that, let's go ahead and place a breakpoint, because if I execute now we will just loop through and log the event. But we want to place a debug point. You do that by setting a breakpoint here. Now whenever we execute, our program will stop here. So let's go ahead and run this, and now oh yeah, I have a visual bug, it picks the wrong main file, but now we can see we have halted the execution, and we can see the input event here, which is nil because we didn't pass anything. But this way you can now go through and debug your code while executing, which is great because you can see the values used and stuff. So that's really useful. So now you can debug and test your lambdas locally, which is great. There's just two more things I'd like to cover really quickly in this tutorial, and one of them is the VS Code extension for SAM, and the other one is how to use and change the Docker network which the SAM application uses. And the reason why you want to change the Docker network is because sometimes your services rely on other cloud resources. Maybe your Lambda will push a file to S3. Now you can't connect to AWS, or you could connect to AWS in your Lambda, but you don't want to. You want to test that locally as well, and you would use local stack for that, which is a great software. But I won't cover local stack. But the thing is, if you run local stack, that runs in Docker as well, so you need to use the same network for your Lambda in SAM to reach the local stack network. So we will cover that very quickly. Let's begin with the extension first. So I don't know if you have noticed, but I have these super nice hints coming up, like do you want to add a debug configuration for this Lambda? And this is the AWS Toolkit extension for VS Code, and it looks like this. And if you're going to use SAM, I really recommend you to download this one. It helps a lot. So if you download this, it will ask you to connect to AWS, and you will get this little button here, which you can use to actually see all your deployed items. So I don't have anything deployed in this account, but you could manage them from here, which is great. But the most important thing is it actually adds these, it actually helps you in your template. So if we take a look at my template, you can see that, like in the API, it says, do you want to add an API debug configuration for this? Because it knows that you will be wanting to debug this. So that's amazing. Also, it helps you with the YAML somewhat. It tells you like what properties and stuff you can use, which is really helpful. So what we can do is we could also go into the SQS Lambda, and if you press add a debug configuration now, and it will ask you, do you want to use Hello Gopher direct invocation, or do you want to use Hello Gopher the API or the SQS? So let's go ahead and do the SQS. And you will see the configuration we created, and this is the configuration that was generated. Now the type here is not Go, it's an AWS SAM, which is a custom type which they have built, and it's a direct invoke. If you use the API instead, it will be an HTTP. And you can see a bunch of other, this is which Lambda to invoke, for instance, this is the name of the Lambda, and in here you can specify the payload to pass. And what's great here is that you can either specify a raw JSON by using the JSON tag, or you could specify the path, which can point to a JSON file. So you could use SAM generate to generate your payload and pass that in using the file path, or you can also put the JSON right here. I usually like to keep the event.json file inside each Lambda, because that kind of serves as documentation as well. You know what the inputted Lambda should look like. So that plugin is really great, and I recommend you to use it. You can also specify the environment variables to use while debugging, so that's also very helpful. And that's also great when you want to kind of break things. You could just change the environment variable really easy this way. So regarding the SAM network, if you're using if you're using local stack and you want to change the network, or if you want to change the network any other reasons, there's actually a configuration option called SAM, and it accepts the Docker network. Let's see if we can make it, yeah, the Docker network. So we can put in the name of the Docker network that we want the SAM application to use while it's running. And let's fix the JSON. So if I were to execute this, I would run on the AWS mock network instead. So that's really useful. And we didn't have to do anything because the plugin generated this for us. Also, if you don't want to use this plugin, or if you're using Golang or any other things, you can apply the SAM Docker network inside the invocation command. So if you go ahead and do SAM local invoke, you can do -- Docker network and type in the name of the network to use. And this doesn't only work for invoke, it works for start Lambda, start API, and the other invocation types there are. So that's what I wanted to show you regarding those two things. So today we have covered how to develop simple lambdas and how to debug them, or at least how to attach the debugger to your lambda. Now it's up to you to actually debug, because I can't help you with that, but you should have all the tools you need to get going. And I really hope you liked this video and that you enjoyed it. And if you liked it, make sure to like it and subscribe, and hopefully I will keep making videos for you.